said applies, right? Take all that as read. I'm not going to contradict most of what he said. But once you've bought into all of that, and then you start saying, okay, now this is all true, now what do we do with it? You start examining the world and you find that actually there were various kinds of species of microservices we have to deal with. It's important to be able to tell the difference between the sheep and the goats in your microservices. And I've always been interested in two particular kinds of microservices. The first of them is what I think of as synchronous microservices. And the second, and logically, is the asynchronous microservices. What do I mean by those two things? So synchronous microservices are typically things that are driven by request response by some user, either as an API service, they're driven by some kind of user interaction. They are things that you request a service and you get a response to it. They are latency sensitive. When somebody says, well, how do you measure success? One of the most important measures of success is the latency that your service introduces into the overall production of some kind of result. You measure the TP99, TP99.9, and these things are, to keep them light and flexible and try and keep them stateless. And since you want to be able to maintain responsiveness under varying demand, you scale out to meet instantaneous demand. You run these things continuously, right? You're always up. This is Amazon retail. This is Netflix. These are services which are run continuously. When things go pear-shaped, you trade off features for responsiveness. If you can't display a feature within your latency budget, substitute something else. If you've got some animated response and you can't generate the animation in time, put up some static content. These things, as Nathan was saying about the microservices, these things are in continuous deployment, continuous development. You're A/B testing everything. There is no static configuration of this stuff. It's always changing on you. Things break in this world, and when things break, what you do is you don't try and say, oh, I've got to make sure that things will never break, or I can roll back a transaction. Things are moving too fast for that. So you look for what I call compensating transactions in your system. Oops, I made a mistake. How can I undo that mistake? The classic example of Amazon was somebody tries to put an item in their shopping cart, and because of the very optimistic nature of the shopping cart, occasionally 2 copies of that item will appear in the shopping cart. Oops, the user will be confused, but you can always catch up with that later on. You can look at when they try and check out, you can look and say, oh, it looks like you may have put 2 copies in there. Check with the user, did you really want to put 2 copies in there? Right? So there are compensating things you can do to make up for it. So these are the web stores, these are the social media sites, these are the Yahoo email and search services and so forth. By contrast, there are still a lot of asynchronous things out there. They are batch processes, they are deadline sensitive, they are not latency sensitive. Right? These are the things where it's often very stateful, and you don't scale to meet instantaneous demand. You scale to meet a deadline. If you are running out of, if you've got more work than what you're going to have, you will add more capacity to meet your deadline. It's typically iterative. This is the kind of thing where I'm computing what recommendation should I show to this user. To do that, I've got to go through that user's purchasing or browsing history, all the other similar users' purchasing browsing history, do some kind of complicated calculation, and come up with a recommendation. You trade off cost for completeness, right? If I want completeness is important here, and I'll actually pay to get things done in time. And these things change at a slightly different rate, and you often, the way you would get around it is not with continuous deployment and instantaneous all, but you'll run stuff in parallel. You'll put a new batch into process into production, compare the data, and then transition over. And you can afford to roll back. These are the website analytics and recommendations engines and all of the other pieces that go to support those interactive things. These are the things which generate the ad revenue that actually pays for an awful lot of the stuff out there on the internet. So, vive la différence. These microservice types are quite different. How we scale them, how we deploy them, how we verify that they're working correctly, what their life cycles are like. What happens when you put them together? When you try and compose the system, right? And what, it's actually quite a common pattern. We've all seen systems which look something like this, or most of us have, I think. You get a website, synchronous website, request response, it's generating behavioral data, clicks and purchases and mouse overs and browsing and so on and so forth. And all of that data, all of the behavioral data that's generated gets aggregated and analyzed. And then the results of that analysis get distributed back to the website system, which uses it to add impressions or recommendations or offers. So you've got this natural pipeline, right? With a website generating a vertical website, it's a synchronous website, generating behavioral data, run it through a MapReduce phase or some other kind of batch analytics every few minutes, pump those results back to a store of behavioral recommendation data which you can then consume in the website. Now, again, aggregation distribution are different kinds of processes here, right? Aggregation is a many-to-one problem. How do I get all this stuff from all these sources into this system so I can work with it? You need some kind of scale-out data collector in there. Some data will be late, fast-track it, normalize it, and so forth. Fluentd is a good example of an open source project which is really revolutionizing the way people think about how do I take large volumes of data from all sorts of different sources and bring it together to work on it. The distributions are a one-to-many problem. I've got this, I've done this analytics, but now I've got this sort of data. How do I get it back? Well, I don't want to just put it in a database. I want to actually aggressively push that through the database to some kind of caching tier. Again, one of the things that Ian mentioned was the use of a large number of denormalized stores. You're trying to reduce latency because latency is one of the realms in the website.
Can I ask you a question?
Yes.
So you mentioned that's a very good point, but I would like to raise a question is if you look at both public cloud platforms like AWS or private like OpenStack, CloudStack, Microservices, they are all not very good at handling synchronous operation. What do you think?
So the question is, the assertion is that the public clouds are not very good at handling synchronous operations.
Let's say about OpenStack.
So the OpenStack is not very good. So we're talking here about application. Now, is it true that the OpenStack simply gives you a set of virtual machines and a set of network primitives to wire up those virtual machines? And if I can build this kind of topology on any kind of cloud or in my data center here. The thing which is the only difference about building in the cloud is that many of those open sources are going to be ephemeral or cheap to deploy. Now, you can argue that some cloud providers are not very good about providing high-performance networking connections in the cloud.
I agree with you, but
well, that's not. That's an argument for choosing a better cloud provider, not an argument about a better application pattern.
When you look at sales provisioning, orchestration, automation, anything being provided by whether public cloud platform or private cloud platform, they all looks like loosely coupled and geared towards asynchronous operation. For sure, they're not very good at synchronous operation. So,
I think we're talking across those systems here. You're talking about the behavior of the cloud as a provisioning engine for building virtual infrastructures to power this kind of application.
Also,
I'm talking about application.
services also okay.
I'm I'm talking about microservices and application packets here, which I can deploy in a variety of different containers, on a variety of different virtualized infrastructures, and some of them will be more efficient than others. And if it's certainly the case that as people move more towards microservice-based architectures, as Adrian was talking about, as they start to recognize the importance of providing differentiated services that will support both the latency-sensitive and the throughput-sensitive parts of those applications, that will drive better architectures from the cloud providers, and eventually even a slow-moving organization like a body like the OpenStack community will come to some consensus about how to do that.
Because the application service layer is totally dependent on infrastructure, right? So which is OpenStack, it's all about.
Well, let's just say that it drives a set of requirements onto the low levels. There we go. Again, one of the things about this kind of model is that in many cases, data doesn't change, right? You get a lot of data. You recompute a set of recommendations. They turn out to be roughly the same as the last set of recommendations. The cheapest update to a database is the one you don't have to make. And so there's actually a really interesting opportunity for data stores which actually exhibit these kind of properties that right through then change things, make things cache easily accessible through cache. And then if you put those together correctly, then you're going to get a harmonious relationship between the synchronous part of your application and the asynchronous one. So let me keep this foundation up here. So all the talk that we've had so far today about microservices and DevOps and agility works for many kinds of services, many kinds of applications, many kinds of solutions. And you really want to embrace those and embrace the practices that that enable that kind of agility. But once you've done that, now you should be sensitive to the differences in the different parts of the services, different kinds of services what you want to deploy to meet those applications, and then customize those patterns to meet their specialized needs. Sync thinks a useful distinction to make, because it turns out to be actually something which drives an awful lot of large-scale large-scale application patterns. And one sort of cautionary thing is that if you look at a lot of tooling that's out there, particularly some of the platform as a service toolings, you'll find that they are written with the assumption that they're dealing with one particular kind of a microservice. So there's a lot of the PaaS tools out there which are sort of written around building out websites like Synchronous applications. There's a lot of other PaaS tools out there that are written around building out complex big data solutions. Map-reduced chains, and so forth. Those PaaS tools don't necessarily compose very well, because each one says, "Here's, I'm in charge of the overall topology of the application," and when two get successfully think they're in charge, it gets a little awkward. So this actually is a distinction which needs to, you need to take into account to drive choices in tooling and choices in the way in which you bring the microservices culture into your organization. So with that, I'm going to hand over to the I think the Netflix team up there, who are going to talk about what they did after Adrian left.
Adrian, so they're still building around the house.
He's still there.